Hey everyone, we had a really great question today about how you can tell if a compound is going to be polar or not. In other words, like water, where it is charged on one side, like positive on one side and negatively on the other side. And that's important to know because it really affects behavior. So I had talked about how the arrangement of the atoms might affect whether it's polar or not, which is true, by the way. So for example, water, which I showed you, because the arrangement means that you're kind of pulled to one side, it's easy to be charged one way on one side, one way on the other. But if you arrange your atoms like very symmetrically, for example, like this one, there's no particular pull on one side or another, and so it tends to be not polar. But what I didn't remember to tell you is maybe the more important thing and the way you can tell in the first place, which is that electronegativity in the first place of two atoms is going to affect how they're arranged. So first you want to say, is there a big electronegativity difference between the two different elements that are being joined together into this compound or molecule? So if you look at water, for example, hydrogen is here and oxygen is way over here. So electronegativity generally increases across the table this way and it increases up. Remember, you colored a periodic table like that. So if there's a big difference between the position on the periodic table of these two elements that are bonded, then there's a likelihood that they're going to be polar or pulled one way or another. So you first say, oh, there's a big difference here, or maybe, two row differences here might make a big difference, or even one makes a difference in your electronegativity. And then if those are electronegatively quite significantly different, that's likely polar. And then you say, is the arrangement also not making up for it? Because if you get this other arrangement, then you're making up for that difference by having it be very orderly, and it makes up for that difference. So those are two ways you can predict whether you're going to have some polarity in your covalent bond, or I guess in ionic bonds too. I don't know. I have to think about that. Anyway, I hope that helps a little bit. Thanks so much for the great question, Tyler.